Hey, congratulations on 5.8 and welcome to 5-9. We're continuing with our discussion of ratios of things, and we're now into proportions. And a proportion is something where you can set it up to be where it kind of shows it under solving proportions, where A over B equals C over D. That's right down here on the bottom of the page here. And that's a proportion. When we solve these, if we know something is proportional, we can use that to find an unknown value. This is what was known in Abe Lincoln's day as the rule of three. When we write this ratio, this proportion, in algebra we write it as A over B equals C over D because this is algebraically useful. You might be used to ratios written as A is to B as C is to D in this ratio form, but that's rather difficult to work with when we're dealing with an algebraic expression. So it's good to know that they mean the same thing, and also good to know that writing it as a fraction gives you something useful. We call these the extremes and the means. The extremes are A and D because they are at opposite sides of this expression. And the means, B and C, are the ones that are in the middle. This is where we get the term of means extremes. So let's take a look at how we would solve a problem like this. Let me pull up another screen here. And for this one, if you got an example 1 in the book, I wanted to go through one with you that would be similar but not the same one. So you could certainly read through that. And let's take a look here at this first example where we complete the sentence. 5 is to 15 as 9 is to blank. Well, the first thing to do when we do this is, well, we want to label it with a variable of some type. So we're going to let x equal the unknown number. And now I would like to write this as a fraction. So 5 is to 15 as 9 is to x. I'm saying it as I write it so I can keep track of what's going on. So this is my relationship here. 5 is to 15 as 9 is to x. I can use algebra to manipulate this, so I'm going to first case, I'm going to multiply both sides of the equation by x. So I get 5 over 15 times x equals 9 over x times x. Well, x over x is 1. That's going to cancel out. And 5 over 15, so that would be 5x over 15 equals 9. Let's make some room here. We'll take our discussion up here. And my next thing, I want to get 15 out of the variable, out of the denominator, but I'd also want to get 5 out. So I'm going to use the reciprocal of 5/15. Reciprocal, remember, is the number when I multiply it times another number, it equals 1. So 15 over 5 times 5x over 15 equals 9 times 15 over 5. What I do to one side of the equation, I have to do to the other one. Well, this is 15 over 15 is 1, 5 over 5 is 1, 1 times x is x. And now I've got this 5 over 15 over 5. Well, I know that 5 goes into 5 one time, 5 goes into 15 three times, and 3 times 9 is 27. And I get here then that x is equal to 27. I could check this by plugging it into both equations. I know that 5/15 reduces to 1/3, and 9 goes into 27 three times, so 9 over 27 reduces to 1/3, and I've checked indeed they do equal the same thing. So this is completing the sentence using the using our algebraic properties to solve this particular problem. The means extreme property is a shortcut to this, and I know you guys all like shortcuts, so let's take a look at how that one would be used in this case. If we use the means extreme property, we had our 5 is to 15 as 9 is to x. Means extreme property means I move everything at one time. I get 5 times x equals 9 times 15. That's the means extreme property. It means I could take these two fractions, I can take the denominators and multiply them times the opposite side, and I'll end up with a new expression. Now I would just multiply both sides by 1/5, and I'm where I was in the previous problem. That's the means extreme property. It's a useful construct to help you when you are working through something like this. There is an activity. I'd recommend you set it up and do it. I have some blocks you can use here to do it in the classroom if you would like to wait and do it in class. It's just kind of a fun way to do this. This is a capture-recapture method. We're trying to get an assessment of a population, and from our sample we have a proportion we can write where the sample relationship should be similar to the actual population relationship, and we can in this case evaluate how accurately that would be true. This idea of capture-recapture it's useful in statistics, and as we go through this we find, well, how accurate is it? And there are, as you go further on in math, you'll find there are statistical tools to allow you to evaluate this and assess the accuracy of this kind of a population adjustment. Let's take a look now at example 2. This is this survey of population. Very common algebra problem. You're going to see this kind of thing over and over again in various guises. But we've got 455 undergraduates have been surveyed, and 409 of them have their own home computers. The actual number of undergraduates is 37,409. This is a good-sized school. Based on the survey, how many undergraduates are expected to use a computer at home? So they surveyed 454. 409 of them had 409 of them had bought that. So 409 is to 454 as our unknown. We're asking the question how many is to the total population. We're assuming that this survey is representative or proportional to the actual school population. From that we get 454 is to x. 409 is to 454 as x is to 37,409. Use the means extreme property. We get 454 times x equals to 409 times 37,409. We are then going to simplify this. They did the multiplication. Now the next we multiply by 1 over 454, and we get that x is approximately 33,701 would be expected to have computers at home. From a statistics standpoint, we would use terms not like absolutes. We wouldn't say there are 33,701. We would say that we would expect to have it, or we have some confidence in there being 33,701, since it is based on a proportion that came out of the sampling. The other way to approach this is the computer ratio. So the number of surveyed students with a computer divided by the total number of students with computer is proportional to the total number of students surveyed divided by the total number of students. Either one of these works out for us as long as 409 is to x as 454 is to 37,409. The number of students in the survey with computers is to the total number with computers as the total number of students surveyed is to the total student population. We solve this, we come up with the similar answer to the two that we got before. And finally, we can end up with some of these proportions that are going to be algebraic expressions. We have two candidates, A and B, and they ran in a village election. Candidate A received 450 more votes than candidate B. Their vote counts were in the ratio of 8 to 3. How many votes did each candidate get? Well, we know that the proportion of A to B is equal to 8 over 3. We know that candidate A had 450 more votes than candidate B. So if we go down into here, we let X is going to equal the number of votes for candidate B. A is equal to the number of votes candidate B received plus 450. And so that gives us our algebraic expression. X plus 450, the number of votes that A received, divided by X, the number of votes that B received, and that equals to 8/3, which is the proportion or the ratio between the two candidates. We use the means extreme property, we apply the distributive property, we're going to add a negative 3x to both sides, and we get then that 1,350 is equal to 5x, and we get then by dividing both sides by 5 that 270 equals x. So candidate B got 270 votes. Candidate A got 270 votes plus 450 votes equals 720 votes. So now we know how many votes each candidate got, and we could also calculate how many total votes were cast. So that's making use of algebra and the idea of proportions to write this problem. It's useful to write it out, get the number of votes divided for A, the number of votes divided for B, which is helpful to write, well, what are the expressions that represent this? Since we have one equation, we want to write an expression with one unknown. Okay, I hope that's helpful. If you want some more help, come and see me. I'd be happy to go through some more examples with you in class and help you to get going on this. Covering the reading and applying the ideas, that's your assignment. Covering the ideas and applying the math, that's your assignment. Good luck on the mastery quiz. See you in class.